Okay, so before we get started, I just want to talk about the minor changes that I've made to our tables so that we're aware of what's going on when it happens. So the first thing I've done is I've added a whole bunch of not null constraints, basically creating required fields for fields that make sense to make required. So I've got not null for name information, for login information, and for a registration date, because when they're registering, we'll know exactly what that date is, especially since we're also having the database default that to the current time at the time when the record's being made. We don't have to specify primary key not null. It's understood that primary keys are not null, and they're like that by default. We don't have to say so explicitly, but I have over here for my example. And also I've set active as not null with a default of 1. How does that look? Oh, in each of my field definitions, notice there's no commas between. One field definition goes between commas, so our first field definition starts with its name, goes with its data type, and then we might throw in some extra modifiers like not null, and in this case identity, and then we follow it by a comma. Then we do the same thing for each of our other fields. Then we get to act registration date, our not null constraints written inline, and then the default value is also written inline. So you just put default. And we're using current timestamp, which will give the current time and date. School year, study, and budget remain unchanged, and here's our active information with a default of 1. Primary key is the same. Looking at post, so I'm just going to switch over to my post tab. So post, same idea. It's got an integer that now has an identity, and it's got a primary key. Then we've got a couple of new not null constraints, a couple of default values. For example, thumbs up and thumbs down will always start at 0 if we were to add it to the table this way. We're actually going to change how we do thumbs up and thumbs down in the future, but for now this is good enough. And post date, we have a time as well, which is not null, and again defaults to the current timestamp. So when a post is made, we know that a post is made at that very moment. That's perfect for our uses. Then we've got our account ID, which is the foreign key. Remember, we do show it in the table design, which is what this is, but we don't necessarily show it in the entity model that we use on our database design. Okay, so it will be an integer just like its counterpart over here in the account table, but keep in mind that it does not get an identity specification. So again, not null, and it's a foreign key. In this case, we've specified that the foreign key is not null. Most of the time, you'll want your foreign key to be not null, meaning that your child data can't be created unless some parent data is there. For example, a post could not be created without also having a user or an account to be associated with. So we set that to not null to make sure we don't make any mistakes. So everything here is pretty straightforward. You've seen all this in the last table. We've got our defaults, we've got our not nulls. And we've set identity for post ID. So now we don't enter the post identity, we don't enter the account identity. All that's handled for us by the database. It creates a surrogate key for us. We've got our usual primary key constraint, and we'll just kind of zone in on the foreign key, and we don't need the Excel window anymore. So we've got our constraint of primary keys. It starts with PK underscore, foreign key starts with FK underscore, and then we begin each of our constraints with the name of the table that we're currently in, so that when we see errors, we know where the error came from. Then we finish it off with a suffix that kind of tells us a little bit more about that constraint. Our naming convention for class is to put at the end of our primary key name, the name of the field to which our primary key will apply. And our foreign key, we put the name of the table to which our foreign key points. So that's where that comes from. Then we say it's a foreign key, and it refers to the account ID here in this table. And it references the account table, and from the account table it gets the primary key, or that column name ACC ID. You no longer have to put in the ACC ID, this one here, because it has an identity specification, which means that the database will take care of that value for us. Okay, and that's it for kind of getting us back acquainted to the account and post tables. I'm going to start a new query window and make sure that I'm still in the right database. And then I want to show you, pull open the Object Explorer just so we have a reference here, because that always helps. And make sure that my tables are up to date by refreshing them. And I'm going to go to my columns for my post table, okay? And I'm just going to try to insert a post for some account ID that doesn't exist. Now we put in 30 accounts, and even though it's identity, we can assume that it's probably good up to 30 because we didn't have any delete errors, but we may run into a point where it does. So I'm just going to kind of overestimate by 2, and I'll try to insert a post for account ID 60. And there's a reason for that, for an invalid account ID. I'm going to do that because, and that's kind of a little bit big for the screen, if we insert into post, and we're not going to mention the post ID because it's being taken care of for us now, but we'll put in a body, and we'll put in, actually let's just leave it at that. Put in post body, and we'll put in account ID, so that's who posted it, all right? We'll put in some values, and our post body is going to say hello that surround the string, all right? And you know what, it's too big for the screen, so I'm just going to say this won't work. And then I'm going to put a comma, and I'm going to put in an ID of 60. Now, as far as our IntelliSense is concerned, it doesn't know whether there's a 60, an ID of 60 in there. So it's telling us everything's okay because it is well-formed code, but it doesn't make it correct code. If we try to run this, we will get an error. And that error says that the insert statement conflicted with a foreign key constraint, gives us the name of the foreign key constraint that we referred to, and then it says it occurred in a certain database, an account, and whatever. But the gist of it is whenever you enter an ID that doesn't exist, and I'll show you, well, I'm going to right click on account, go to select top 1000 rows, and if we scroll down, looking through these account IDs, you'll notice there's nothing over 30 right now. And that was the whole reason. I wanted to show you that when you put in an incorrect foreign key ID, you will get this error. So if you see conflicted with foreign key constraint, doesn't matter what it is, it means that you put in an ID here that doesn't exist. Okay, so we've got a couple of names on that list. Let's have another look at those. And I'm going to put them, new horizontal tab group. All right. Pull that up, and let's just grab a name here, Amy Clark. All right. So let's grab Amy Clark. Remember that I said that you don't put in IDs manually if they're not given to you in a question. So let's say insert a post, let's call it a hello world post for Amy Clark. Okay, so we're going to try to insert into post, and we'll just put a post body and a post account ID, the person who posted it. Okay, and values will be, now why did I not put any of those other fields? Because they're nullable or they're already defaulted for us. So thumbs up, thumbs down, and post date will be whatever day that we insert that in, right? So I'm going to put in values. My post body is just going to say hello world, and then I'm going to try to insert for Amy Clark. Well, visually we can see that the account ID is 7, but if it's not provided to you in the question, you can't go looking it up, because what we're trying to do is create a database that can do the looking up for us. So never put in a foreign key ID literally. Instead of putting in the foreign key ID, we put in a subquery. So we say select, and we grab the account ID. That's what we're trying to put in here is an account ID. We just have to get it from the account table for the correct user. So we say where, and I'm going to pin that off. Hopefully we can keep this on the screen here, where first name is equal to, her name's Amy. I could not keep it on the screen. Oh well. Here's what I'll do is I'll put this on the next line. And last name, there we go, is equal to Clark. Okay. We don't have a closing bracket yet, so let's do that, and now we're good, okay? So it's a bit long there. Let me just put it on one line because this is how I would probably write it on my own screen. All right, I just like to keep it large so that it's easy for other people to see here. And this whole subquery is substituting with the account ID from the row that we found this person's name at, and putting it in place of the account ID value in our values list for what we're inserting. So this should be successful, okay? And you can see right here, one row is affected, so yes, it was successful. Now I'm going to insert a hello world post for Bob the Builder. Okay. I don't take this whole thing. We can pretty much use the whole query, except we've got to change the names, right? So we go Bob the Builder. Okay. As a rule, always use both names. If you're given a first name and a last name, make sure you use a first name and a last name. If you're given an entire company name, make sure you use the entire company name. Don't use partial matches, because what if there's another thing that matches that smaller bit, right? Okay, but let's try to run this and see what happens. We hit execute, and it says cannot insert the value null into column account ID. In this case, it's because Bob the Builder does not have an account, so we don't get anything back from our subquery. So if you get that, cannot insert value null into column account, and you're using a subquery, it's because you mistyped something somewhere, okay? But if we have a look through here and we look, there's no Bob the Builder. You look all you want, he's not there. But maybe we change this up and it becomes Bruce Kelly. Bruce Kelly. Let me try writing that one. We're good to go. That's one row's affected. By the way, we can confirm that we got those in there. Okay, we just go select star from post and we load those up. I'm going to get rid of this account table. We don't need it anymore. All right, so we've got all of our posts right now, right? And there's currently a couple hundred posts in the database, so I'm just going to scroll right down to the bottom. You can see the new ones that I added. Okay, so I've got Hello World, and there is account ID 7 and account ID 2, and I'm sure you can confirm, if you really want to, you can go back and confirm that these are the users, Amy Clark and Bruce Kelly. So we've tried to do things the correct way. They're automatically set defaulted to 00, and as you can see, it is currently 11:38 in the morning here on Friday, February the 10th, and that is when I had these things put in because it was using a current timestamp. They both say hello world, and IDs were automatically assigned to them because of the identity specification. You remember how I said sometimes sometimes the identity specification skips a value? Well, that happened here twice. In this case, because we tried to insert things that didn't work the first time. And that won't always happen, but you can't count on it not happening either. Okay, but we also, maybe we want to look for a specific post or post by a specific person. We can select everything from post where the account ID is equal to, and then we can grab, maybe we want to find all of Amy's. So we can grab that same subquery, we can get her account ID from the account table as long as it's for her record, okay? So we try to run that and we hit execute, and these are all of Amy's posts. You can see her account ID is 7, and again we can get Bruce Kelly, okay? Do a select there, good to go. So this is how we can use subqueries inside of our inserts and the types of errors we might get if we do those things incorrectly. So now we've kind of seen this select where we grab for a certain person, right? And we're grabbing all the posts for that related person, but we're only outputting the post information. What if we wanted something a little cleaner? For example, so a new query window, and I'll paste that in, and we'll zoom in just a bit, okay? Now, let's suppose for a post we want to output the post body and the post date, and we want thumbs up and thumbs down. Okay. This is good for that. We can keep our posts real simple, and for the most part we can get all the information we need while we're on a particular account screen. For example, when we're looking at somebody else's profile page and we see just their posts on their page, this is the kind of information we might want to pull out. However, if we're looking at our post reel, we may want to see something about a given post and get the account information from it. So let's say we get just let's grab a random post for now. I'm going to get post ID number 173 because I have no idea who that is offhand. So I want to get post body and that kind of stuff, but on my post reel or my news reel or whatever it's called on Facebook, I can't remember, we would not want to get by a particular account. Instead, we would be getting just from a given post, and that post ID would be provided to us on the page because it was grabbed from a random list or something along those lines. So we have where post ID. We don't need where post ID. No, we can't use a where in this case, especially if we want to get an account from the account list. And so your first instinct might be to just find out what the post's account ID is, ACC ID, and then use whatever that is to grab account information from account. So you can't use IDs, so you're going to go where post ID equals, and then you have to somehow figure out what the post ID is over here. And so it just doesn't make sense to go to all that work. What we could do is something that at first the syntax might feel a little bit funny, but the reality is that it's actually quite easy to put together this join syntax. Now what we're going to do is we're going to do what's called an inner join. Okay, now an inner join does kind of what you might expect of it. It grabs everything and joins two tables on some criteria we provide, puts them together, and brings them all inside a new data set. And then that's what's provided to the from clause. Okay, so our from clause is not just about one table, it's about a table and potentially joining many other sets of tables. Okay, and what we want to do is we want to grab account information about the account attached to this post. So we say that we want to join the account table in, and we do that by telling it how to join. We say on, and then we provide what looks like where criteria. We're going to say where our post's account ID is equal to our account's account ID. Okay. So it's kind of like a mini where clause, but it's specifically meant for putting together two tables. It's used so that when a new post record comes out, the database engine goes into the account table and looks for all of the accounts that match this account ID from the post table. So this is actually pretty good. I'm going to take this off just for a minute. We'll talk about why I have a red line there in a minute. There we go. Now if I run here, I hit F5, you get a whole bunch of information. And not only that, but you'll probably notice that we've got all of our records right now. And what we wanted was to get a particular post ID. So now we can put a where clause that says where post ID equals 173. Okay. So we're looking at a specific post at this particular moment. Right. Now we want to get account information. What was this join all about? Well, the join was to show our account first name, account last name. This tells us who wrote that post, Jerry Washington. Okay, and of course we could always concatenate. So concat ag first name, ag last name as ag full name, right? Perhaps. And we're missing a space there, so let's throw that into our concat list, right? Put a space in between. And now we got a full name with a first name space last name. Okay. So this join, what it did was, I'm going to look at our diagram again. Okay. We used our relationship from our account table to our post table, knowing that the post table, because it has the fork stuck in it from the crow's foot, is injected with the account ID. We say we're grabbing the post's account ID and we're matching it to any accounts that have the same account ID. Okay, and because of the nature of a one-to-many relationship, when you join it that way, your posts will always have one account. So it only needs to join once, and the database engine is smart enough to know to stop there. So it gets done really efficiently in the background. Okay, so that was for a post. It actually can go either direction. We can also get all posts for, how about this guy up here, this Bruce Kelly guy. Okay. Let's grab this original query, and let's say rather than grabbing just the post for that guy, let's grab the posts for that guy in a little bit of a different way. Okay, so we're going to start with account, so I can show you that the join will work in both ways. We're going to go inner join, and we're going to join post on, again, account.acid equals post.acid. I find it helpful to go from parent to child when I'm doing these joins. So this first way was just showing you can do it, but I suggest that you take your parent table, you find whatever relationship you're trying to join on, you look for the single side, and that's the table you write in first, and you look for the triple side or the forked side, and you write that table next. So you can see I've got account, and then I'm joining post. So account, post. And then I'm joining them on, again, account, post. This is just helpful to keep things organized, and later on when we're doing multiple joins of multiple tables at the same time, it will be easier to follow what you're doing if you go from parent most to child most table. Okay, so we just now say where account first name equals Bruce and last name equals Kelly, and we've got ourselves a full list of Bruce's information. But of course we may also want to output his name, so add first name, add last name. We've got all that. You know, how's he doing for thumbs up and thumbs down, right? Maybe we can find out about popularity of a particular person and their posts using this information. And now we get into a situation where we may want to start using aggregate functionality to show information about our users' outputs. Okay, so for Bruce Kelly, when did he first post something? When did he last post something? And how many thumbs up and thumbs down did he get in total? So we can actually take this whole thing here. We can make sure we're dealing with Bruce Kelly here, okay? And we can take out his first and last name, his body. We'll leave the post date there because we're going to use that for a minimum. That's the earliest one. And we're going to copy that to another column. We're going to put that as the maximum. Max. All right. And now you might think that you're looking for a count of post thumbs up, but that'll just give you one for each record. Count 1, 2, 3, 4, 5. If you want to add those things together, you need to use the sum. Sum is, in that case, you use sum. It's 2 plus 4 plus 7 plus 20 and so on. Okay. And now we do a sum on post thumbs down. And normally we put labels there. I'm going to just show you what we get, and then we'll put the labels in. Okay, so this is the first time he posted. This is the last time he posted. He's gotten 83 likes and 31 dislikes. So people disagree with him, all right? Let's put in these labels, and I'll fast forward this to okay. So just so you know, it looks a little nicer. You see how we've got all these no column names. There's no way to differentiate between them except for their order. Now we know for sure we're talking about first post, last post, thumbs up and thumbs down. We might also add some formatting on the dates. For example, I might go format, and here put lowercase d for my date, format. That's just one of the formatting codes here. If I put a lowercase d, it'll automatically turn it into a short date for me. Okay. Or I can put a capital D and it'll give me one of those awesome dates that's a little easier to read. Okay. So lots of interesting things you can do, and you can keep molding your data as you go and keep just adding levels of complexity to pull out information in exactly the way you want. But I do suggest that, like I just did, start simple, start small, and build your way up after that. So what's next? Okay, so we got just for one. What about if we wanted to get information about everybody from the same school? Okay, so again, I'm just going to grab everything this time, and I'll show you what happens when I do that. I'm going to grab everything from account, and I'm going to join post. By the way, we're not going to post. Okay. By the way, I can shorten inner join to just join. There are many kinds of join in SQL, and inner join is the default, so if I don't specify, it assumes an inner join. So I can say join post. And tell it how to join. Don't worry, this is not case sensitive, so I can say on account .id post .id. Remember, we're not joining a primary key to a foreign key. We're joining the parent table's primary key to the child table's foreign key, because the child table will refer back to the parent, and that's the whole reason for this on clause, is to tell us how to put the two together. Okay, and we're going to say where school equals, and let's try Niagara College. Okay. Now these are fictitious people. You're not going to walk around the school and find them here. All right, but as you can see, first of all, we get all of their account information here. Account, all the way up to account active. Then we get our post information. Okay, all the way up to the post foreign key account ID. All right, that's a lot of information. We don't need all that information all at once. Usually we take this information, we put it together, and then we kind of deal with what works with that. What I'll point out to you is that you will see accounts repeated multiple times. Okay, we've got Timothy Ortiz several times here, here. Amy Clark, we already know she has multiple posts, right? And what's happening is, because of how joins work, it repeats the output of something that is joined to more than one of the other entity. Our account is joined to more than one post, so we see the account once for each post. We still only see one post because it's the child table and it doesn't have anything to join to more than once other than joining back to the account it belongs to. That's a lot of information on our screen though, so let's shorten it down a little bit. Let's just output their first name. No, let's output their full name. Let's use that concat, or just do act first name. Let's do the other way of concatenating, act last name. All right, and we'll call that act full name. That's our label here. We're gonna need lots of lines, so I'm gonna put it on the next line this time. And what we're doing is we're getting all Niagara College students and their posts. Okay, so we'll also output, we'll just leave their name for now. We'll leave their name. We already know that they're at a school, whatever. We could output any other information from their account. In fact, let's do this. Let's do account active. Okay, we want to know whether or not they currently have their account alive or if they've canceled their account. Okay, so we've got a few who don't. Maybe we should filter those out as well. So we're going to say we're act school is Niagara College and the account is still active. Okay, good. Okay, so the next thing is all Niagara College students and their posts. So that's just outputting the account information. Let's output the post information. So we put out the post body, and for the record, let's put out their thumbs up and thumbs down. And we'll leave it at that. Okay. Now let's suppose we want to figure out for each person in this list, we want to output how many total thumbs up and thumbs down that they got, right? If we copy and paste this, I'm just going to copy, paste, all right? We'll not output their post body anymore, but we're just going to say all total thumbs up and down, okay? So we'll need their name because we wanted to talk about who gets the thumbs, right? And actually it shouldn't be all, it should be each Niagara College student total thumbs up and down, all right? So we can keep our work criteria because we're filtering down our original list, the list from which we are going to get our aggregate data. So we're going to get a sum of post thumbs up just like we did before. And we're going to say as total thumbs up, okay? And let's just change this for down here. Maybe do thumbs down and total thumbs down. And we'll get rid of that extra comma and we're good to go. So I tried to run this and I'm going to get an error, okay? This error is it's invalid because it's not contained in an aggregate function or the group by clause, and it's talking about this account first name field. Now it stopped here on the account first name field, but the truth of the matter is the same thing applies to account last name. If you have a look, account last name doesn't exist in an aggregate function either. And it also says or the group by clause. What does this mean? We'll discuss that in just a minute. So what will happen here though, you think, okay, they're in the way, let's just delete them, and that's kind of seems like it makes sense, and then all of a sudden we've got the total thumbs up and thumbs down for the whole school in one row, and that's not what we're looking for. We want to see for each of our Niagara College students, right? So if we want to output a first name and a last name, it means we have to take the data that we're getting, so this data here, we have to take it and we have to tell the database to group it. I'm going to order by just to display this. I'm going to go and order by act first name, act last name. All right, good to go. Now we can see we've got Amanda Brown and all of her posts. All right, what we want is for the database to make groups out of each of our students, make groups of records and run the aggregate calculations on each group. So we've got Amanda Brown's group, we've got Carolyn Tucker's group, we've got Daniel Pierce's group, and so on, right? And we want to get, subdivided data based on those groups. So what we can use is something called group by, okay? So our select queries, we said earlier in the term, there's a couple of clauses, and they go in the order select, from, where, group by, then having, and then order by, okay? They must go in that order all the time. You can't mess with the order, okay? Within the from, you may have optional joins, okay? In the where, you have criteria, and that's not optional at all. You just have criteria, all right? In the select, you have your select list. You need at least one output field. In your group by, what you have is a list of row headings, okay? And that can be a single row heading or multiple row headings. Having is criteria after aggregation or running aggregates, okay? So this will test the result of your aggregate values, okay? And criteria here works very similarly to your where criteria, so it's easy to get them confused, and we're going to have to discuss how that's done in just a minute. We're going to get there, but just talking about all these things in the right order, we need to put a group by here after the where. We go group by, okay? And the rule is don't put all of your columns from your select list in there. You want to put any of your columns from your select list that do not exist within the brackets of one of these aggregate functions, okay? So we take act first name, we put that in the group by, we take act last name, and we put a comma, we put that in the group by, okay? And we hit F5, and now you can see our 4 Niagara College students and each of their individual thumbs up and thumbs down counts. Now you don't always need a join for a group to work, it just mostly makes sense for grouping to work on a join. If you have well-formed databases. I've kind of on purpose left kind of some mistakes in the account table, so I'm going to show you what I mean here. Select star from account. Okay, I'm just going to grab everything from account. And what we have here is a school list, and we see the name of the school repeating multiple times. Later on, we're going to refactor this out. The school name should not be in this table. If we're using the same thing multiple times, we really should have it out in a separate table. So we have a table of schools and instead have the account refer back to the school. So it'll be a child table of the school. And so Niagara College might have an ID of 1, so that's what our account would have. Sheridan might have an ID of 2, so that's what our account would have. And the same thing applies to the field of study. The years doesn't really make sense to break them out because they're already integers, and so we're not exactly saving space or time by doing it. And budgets, if they overlap, it's a fluke. Things that we expect to repeat, we'll definitely want to have outside in other tables, and we'll give that a little bit more thought at a future date. For now, just keep that in mind. I don't want to confuse you into thinking that these things should be here, but I do want to show you how group by can work in a single table, and I think these are a perfect way to show that, all right? So I'm going to put act school, okay? And I'm going to get a count of the number of students. Okay. Not only that, we can also say where they have active accounts. Okay, so we just have to group by act school, okay? And we run it, and we get for each school that's there, we have the number of students that are in our database and who still have active accounts. If I take off the active, you'll notice that number grows. Okay, and it looks like we also have a school where everybody has, what's that, U of T and York U at the bottom? Let's see if one of those was the ones. Nope, they're not the ones. Anyway, one of our schools doesn't have anything. the whole null thing, that's just a count of the students who didn't provide a school, and so they have null in their school value. If that bugs you, if you don't want to see that, and you often don't, we say where act school is not null, and that kind of cleans up our list a bit, right? So we don't have that null in there anymore. Okay, so we understand grouping, hopefully by now, and we've got a good idea of aggregates. But let's keep in mind that if you're going to use group by, then it should be used with aggregate functions. However, it doesn't always work the same way around. If you're trying to just get aggregate data on all the data in your database, you'll never need a group by. But most of the time you will. So most of the time it works the other way around. Okay. Group by also goes hand in hand with having. Okay. Now having is a where clause. It's a late where clause. Okay. Now your where clause happens before grouping, your having clause happens after grouping. It's an execution order thing. So while our select statement is in the order we're used to, group by, having, which we'll discuss in a moment, and order by, this is the way we have to write it in. So this is our writing order. But the execution order is a little different, okay? The execution order works like this: from, where, group by, and then select, and then it works on its having stuff. Or you could say then select and then order by. Either way, all the lower written functions are done in execution order. So we'll change execution order. Are done in this order when we're talking about execution order in the database. Okay, so first it gets its data set, get data set, okay, then filter the data set, okay, then here set up groups, okay, then here it says, well, aggregates, and actually in between here there's kind of this hidden thing here where it's aggregates are processed. Okay, and having can filter grouped data by some criteria. Okay. Then select, display output, and then order by is sort output. Okay, so these are the steps that the database goes through. What this means is that the having clause has access to aggregated answers, so our sum, count, min, max, whatever, is available in the having clause directly. If we want to use it in our where clause, we can only ever use aggregates. Can only be used in subqueries. Right? Can only be used in subqueries. Right? Let's do a query here where we check. Let's start with show number of posts per student. And we'll do that for all students this time, so we've got a lot more data to work with, all right? We're going to do select, and we'll get their first and last name again. Let's start with star from account, and we're going to get ag first name, plus a space, plus ag last name, and we'll name that the full name. Okay, and we're going to do account star, but what are we counting at this point? Just accounts. We need to join in their posts. Okay, and we'll do that on account. Actually, it's not called posts, it's just posts.acid equals post.acid right there. And here we're going to say as number of posts. Gotcha. Good to go. So it's for all students right now, and it's telling me, I almost forgot about this, that first name is invalid because it's not contained in an aggregate function. If you double click on your error, you'll notice it'll highlight the line that's responsible. Okay, so we want to make sure that we have a group by first name And we'll get the same error for last name if we don't take care of that now, so we will. Basically anything that's not inside brackets needs to be in a group by statement if that's how you're going to do it. And they should be considered group headings or row headings. So we're grouping for each first and last name combination. We are outputting the count or the number of records that we produce. When we join in our post table, that means that we're counting the number of posts that we have for each person. Okay? So when I run that, you can see I got a ton of records here, and it took actually a moment to execute that. And I'm just looking here, and we got a few that are above 10, so that's what I'm going to use here. All right. So show number of student posts per student, but I'm going to say where the student has posted more than 10 times. Okay. Key language there is more than, not 10 or more. So more than means that we're going to say something is going to be greater than 10. What is that something? Well, if we're having a look, we want to get this number of posts to be greater than 10. So let's try a couple of things. I'll show you a few things that won't work. You should not do where count star is greater than 10 in the where clause. Okay, so that won't work. All right, so it says an aggregate may not appear in the where clause unless it's in a subquery contained in a having clause or a select list, and the column being aggregate is an outer reference. Well, that's a long way of saying it should be in a subquery. So an aggregate can only be in a subquery. Okay. So we think, okay, well then let's say, what if we have something, maybe post something is equal to select count star from posts. And now you're starting to get a little bit into this area of what the heck's going on, right? So a subquery is not the best way to handle this. What we probably want to do here is we want to use this new having clause. Now having happen because it happens after aggregation, so after our aggregate functions run, we now have access here directly to our count, and we can say if it's greater than 10. Okay? So now we're only outputting the students in our list who have posted more than 10 times. Okay? What if we want to find people who have posted less than 5 times? I wonder if there are anybody, because the randomization works that way. Okay, let's try 7, less than 7. Is there anybody? All right, so we got a few that did less than 7 times, right? Gives you a clearer idea of what's happening within a particular subgroup of your people and so on. But definitely the rule is can only use aggregates directly here. So those are min, max, average, sum, and count. Okay? And whether it's a count star or a count of a particular field, it still applies. In the where clause, we must put it in a subquery, which we've been doing when we're trying to find the person who had the minimum number of something or the maximum number of something. And it made sense then, okay? So we're looking for a single answer to something, or if we're looking for people who have more or less than the average, where it becomes a two-part question where you have to figure out something first and then get the answer. Where here, it's kind of the same, but it's a little bit of a reverse order thing. It says show all the posts for, or the number of posts for each student, and then filter it by making sure that they have more than 10. So let's change that back, by the way, more than 10, so that it's correct when we show it on the screen there. And that's how having works. And we'll do lots more examples with having, but that's a good start.